Alright guys, so this podcast is still on solving systems of equations. Alright, you've already learned how to solve systems of equations by graphing them. So now we're going to look at solving them without graphing them, but by using algebra. Okay, so we're going to do this with two methods. The method we're going to do on this podcast is to solve systems of equations by substitution. Alright, and we've been doing substitution since chapter 1. Okay. Back in chapter 1, we were doing very simple substitutions. Here, it's the same idea, it just looks more complicated. So once again, substitution is to put in the place of a variable. Right? That's what we're doing. We are substituting something for a variable. Today, we are putting an expression in the place of a variable. Okay? So what that basically means is, back in chapter 1, we were doing some simple stuff like if you're given an expression like 3x plus 2, and then it would say x equals 4. Well, you're plugging in the 4 in for the x, right? And once again, what we said when we did that is to substitute with parentheses, like that. And then you PEMDAS it, right? Same rule still applies, it's just that now we're not going to be plugging in just one simple number. We'll be plugging in something else, but we're still just plugging it in. Alright, so going through here, the goal for solving by substitution is to replace either the x or y values with an equivalent expression. So that's the thing. You can substitute for the x or the y. It doesn't matter. Really, it depends on the problem. Some problems substituting for the x is easier. Some problems substituting for the y is easier. Alright, and so we'll kind of look at those examples. Alright, so here are your steps. Step 1, select one of the equations in the system and isolate one of the variables. Your choice, because we can do the x or the y. Alright, so once you've selected one and you've isolated the variable, step 2, you're going to substitute the result from step 1 in the corresponding variable in the other equation. Okay, so once you've gotten y equals or x equals by itself, you're going to take that and plug it into the other equation. Step 3, you're going to substitute the result of step 2 into either one of the original equations and solve for the remaining variable, meaning once you found x or y, you're going to go back and plug it in and find the other one. Okay, the solution for the system must be expressed as an ordered pair. Remember, we're writing the answer like a point, because like you did earlier with the graphing, the answer is technically the point where both equations cross over or intersect. Lastly, check your solution. It must work in both equations. Okay? Right? Because we're not looking at just one equation, we're looking at both of them together. Alright? This all does kind of sound like a lot. It'll make more sense once we actually just get into it and do the problem. Okay? Alright, so let's look here at example 1. Okay, they're going to tell us to solve by substitution. Here's our original system of equations. We have negative 3x plus y equals negative 6, y equals negative 6. Okay? Step 1 is to get the x or the y alone. Alright, now lucky for us, so this is why you got to look at every problem before you do it. This problem is already ready. This is already y by itself. So this will allow me to substitute negative 6x for y. Okay? So here's how we're going to do that. So step 2, substitute into the other equation and simplify. So I'm going to take this and I'm going to plug this y value into this equation. Alright? So we'll write that out over here. So it's negative 3x plus, if y equals negative 6, I'm plugging negative 6 in for y. Substituting with my parentheses, negative 6x equals negative 6. Okay? So we've just done that. So now we have to solve this. In this case, you see we're going to solve for x. So we're going to combine our like terms. Negative 3x plus negative 6x is negative 9x equals negative 6. And we're just solving like normal. Divide both sides by negative 9. X is finally by itself. And if you do that in your calculator, it'll simplify it to a positive 2 over 3. Okay? So all we've done at this point is found the x value. Okay? Which is step 3, finding the missing variable. Okay? So Now, I'm sorry, now we have to do step 3 and find the missing variable. We still need to find y, okay? So what we're going to basically do now is we have this x equals 2/3. We're going to take this and we're going to plug it back in. It doesn't matter which one I plug it into. I can plug it into this one, or I can plug it into this one. It doesn't matter. I'm going to plug it into this one because this one will just be less work. It'll be y equals -6 times the x. Alright, so now I'm going to do y equals -6, parentheses, I'm going to plug in my x, and we said x is 2/3. Okay, so now we're just going to punch that in your calculator. -6, parentheses, 2/3. And if you punch that in, you're going to get -4. Okay, so that brings us to step 4. Write the final answer as a point of intersection. Remember, it's always x value, y value. So the x was 2/3, and the y was -4. Okay, so that's what we're doing here. So once again, to recap what we did, we need to get, the variable by itself. In this case, the variable is already by itself. This is easy. So we just plug in this for y on the other equation. So we plug the -6x for the y. We solve for x. Once we got the x, we went back and plugged it in. It doesn't matter which one you plug it in, but I chose this one because it's going to be just a little easier. It's going to be y equals -6 times the x, which was the 2/3 when you plugged it in, and that's how you do it. Okay? Let's look at a little bit of a different example. An example 2. Once again, solve the system using substitution. Step 1, get x or y alone. It doesn't matter. So now if you look at these two equations, -x plus y equals 6 or 5x plus 5y equals 10, you'll notice we're not as lucky this time. None of them are x or y by itself. So on this one, we're going to have to do a little bit of work to get the variable by itself. So if we look at this one, I do think that this one will be a little easier. It'll be less work because there's no number in front of the x and y, right? So now if I choose, am I going to get x by itself or y by itself? I'm going to choose to get the y by itself. Once again, it'll be one less step because the y is just sitting there ready, okay? So to get this by itself, I'm going to have to rewrite it and work it out. -x plus y equals 6. So to get y by itself, to get rid of the -x, I'm going to add x to both sides. So y equals 6 plus x. Alright, this is what I'm going to substitute. Okay, I'm going to substitute 6 plus x for y in the other equation. So because I took that one, I'm going to plug it over here. Okay, so let's go ahead and set this up. 5x plus 5y equals 10. I'm going to plug in this expression in for y because it says y equals that. Alright, so we're going to go 5x plus 5y. Remember, now substitute parentheses. And I'm plugging in 6 plus x for the y equals 10. Now I just solve it like a normal equation. I do need to distribute first here. So it'll be 5x. 5 times 6 is positive 30. Positive 5 times positive x is plus 5x equals 10. Alright, now if you look here, I need to combine my like terms. I got these two x's. So 5x plus 5x is 10x plus 30 equals 10. Then we're starting to get the x by itself. So we will subtract 30 first from both sides. 10x equals 10 minus 30 in your calculator is -20. Divide both sides by 10 as the opposite operation. X equals -2. Alright, so this is half of my answer. That's my x value. We need to find the y. So remember, to get the y, you're going to take this and plug it in. Okay? So if I look at these two equations, make it easier. I think it'll be easier to solve this one. There's a little less going on. So I'm going to take this x value and I'm going to plug it in here. Okay? And then we're basically going to solve that. Alright? So notice this equation is -x plus y equals 6. Remember, when it's negative x, you got to put the negative. There's my parentheses for my x value, and the x is negative 2. So really this turns into negative negative 2 plus y equals 6. So plugging it in here, now we're going to solve for y. Negative negative 2 really means positive 2. So this is really 2 plus y equals 6. To solve for y, we subtract 2 from both sides. That's gone. Y equals positive 4. Okay? Alright, so now once again I need to write my answer in the form of an ordered pair or a point. So here's my x, here's my y. X was negative 2, y is positive 4. Alright, so that's the point where both of these equations intersect or touch. Okay? Alright, let's go to the next page on number 3 here. Okay? Oh, and this one says don't forget to check. Alright, so we'll practice checking with these ones. Alright, so now they did not give us all the steps. Okay, so now we're just going to kind of try without seeing all the steps. But the question, which is better variable to isolate? Which is the better one? So look up here. Hopefully you'll notice that this x would be the easiest one to isolate because, you know, it's already almost by itself. Okay? Technically you could do anything, okay, on your own. Alright, but since we're doing it together, so we will first get rid of, or we will solve this equation for x. Okay? So the last two we solved for y the first time. Now we're going to do x. That's okay. It doesn't matter. Alright, so let's come over here. We're going to take the 2y minus x equals 8, and we're going to start solving for y. So to get rid of the 2y, we do minus 2y on both sides. We now have, careful, negative x equals 8 minus 2y. Alright, and then finally we got to get x by itself. That negative x means negative 1x. So we're going to divide that by negative 1. We're going to divide everything on the other side by negative 1. So finally x is by itself. Positive 8 divided by negative 1 is negative 8. Negative 2y divided by negative 1 will be plus 2y. Alright, so all we've done is we haven't done any substitution yet. Now we're going to substitute this negative 8 plus 2y in for x. And once again, we're going to plug it in for the other one, the bottom one in this case. Okay? Alright, so let's get ready to find our first value. So we're going to take 2y plus 2x equals 2, and we're going to plug that in for the x. So 2y plus 2 parentheses for the x, and I got to put all this in. Negative 8 plus 2y, close my parentheses, equals 2. So once again, I've taken this whole equation, plugged in the x that I found. Now we're going to distribute first. So this is going to be 2y. Positive 2 times negative 8 is negative 16. Positive 2 times positive 2y is positive 4y equals 2. Alright, so let's clean this up. Combine our like terms. I got 2y plus 4y. So that is 6y minus 16 equals 2. Okay. Alright, so now we're going to solve for y. So we're going to add 16 first. That's gone. We're left with 6y on the left side equals 2 plus 16 is 18. Almost done. Find y by dividing by 6. Y will equal 3. Alright, so we finally got half the problem done. We have the y value. Now we need to find the x value. So what we're going to do is we're going to take this y equals 3, and we're going to plug this in for any one of the equations. It doesn't matter in this case. Okay? I'm just going to choose to put it in for the top one now. Okay? You can do the other one. Alright, so if I plug that in, I got 2y. Whoops, I need to plug 3 in for y. Let me fix that. So it'll be 2, there's my y value, and I'm plugging in y equals 3. So 2y is 2 times 3 minus x equals 8. So now we found y, so now we're going to find x here. 2 times 3 is 6 minus x equals 8. All right, solving for x, got to get rid of the 6 by subtracting 6. Negative x equals 8 minus 6 is 2. Got to get rid of the negative in front of the x, so we're going to divide by negative 1. Do the same thing on the other side. X will equal negative 2. All right, last thing we need to make sure we do is write our answer in the form of a point. So our final answer is, make sure you put the right one in the right place. The x was negative 2, the x goes first. X value, then y value, y equals 3. This is our final answer. Okay? All right, now just to get in the habit of checking it. So once again, anytime we check anything, we're basically just plugging it in. And we can use our calculator for that. Using the storage key is probably the easiest way. All right? So I'm going to have to go back and forth here. So first I'm going to store in my values. Negative 2 for x and 3 for y. All right, so we're going to store negative 2. Remember the storage key for x. Enter. So it stored that for us. And now I'm going to store in 3 for y. Okay. All right, so now I've got to check it with both equations. So now that I've stored my values, I'm going to type in this first equation first. 2y minus x. All right, that's the left side here. 2y minus x. So now that it's stored, I can just type it in. 2y minus x. Let's see what that equals. It equals 8. And if I look back here, that's what I want, because when I check it, the left side was 8 equals the right side was just 8. There's nothing to do. So this one checks out. That's our reflexive property. Now let's check the second one, because they both have to work for this answer. I already stored these values. I don't have to do it again. I'm just going to type in the left side. 2y plus 2x. So I'm going to come here. 2y plus 2x. And let's see what that equals here. That equals 2. Okay? So let's come back here and take a look. So when I did the left side, this whole left side equaled 2 equals the right side is just 2 by itself. So both check out. These don't have to be the same here and here. It's just left side equals right side, left side equals right side. All right, so that one is complete. All right, last one we'll do together here. So solving by substitution again. Here is your system. First equation is 3x minus y equals 17. Second one is 4x plus 2y equals 16. Once again, this one, none of the variables are by themselves. I'm going to have to get a variable by itself. And looking here, I think using the first equation and getting y by itself might be the easiest. Okay? So I'm going to start off by getting a variable by itself so that I can start substituting. 3x minus y equals 17. To get y by itself, we've got to first move the 3x by doing the opposite, minus 3x. Left with negative y equals 17 minus 3x. And then remember, this negative y is like negative 1y. So to get that off, I got to divide by negative 1. And then on the other side, I got to divide every piece for every term by negative 1. So here y will equal positive 17 divided by negative 1 is negative 17. Negative 3x divided by negative 1 will now be positive 3x. So I'm going to plug in negative 17 plus 3x for y, because that's what y equals. And once again, I'm going to plug it into the other equation. This is the other one, the one that I didn't mess with yet. All right, so let's take this equation. 4x plus 2y equals 16. And I'm going to plug this in for the y. All right, so 4x plus 2y, and my y is negative 17, plus 3x, close parentheses, equals 16. All right, so now we're going to solve for x, get our x value. We're going to distribute first. 4x, positive 2 times negative 17 is negative 34. Positive 2 times positive 3x is positive 6x, equals 16. All right, let's combine our like terms. 4x plus 3x is 10x. Still got that minus 34 here, equals 16. Solving for x, Get rid of the minus 34 by doing plus 34. We are left with 10x equals 16 plus 34 is going to be 50. To get x by itself, divide both sides by 10. X equals 50 divided by 10 is 5. Alright, so we finally got halfway done. We have our x value, x equals 5. Now, we're going to take x equals 5, and we're going to go back and plug it in to either one of these equations. I'm just going to do the same one again, okay? Doesn't matter which one. So now I'm going to plug 5 in for x here, okay? So I'm going to take 4x, 4 parentheses x, my x is 5, plus 2y equals 16. Alright, so we start solving this. I need to do the 4 times 5, so that's 20, plus 2y equals 16. Solving for y now. Get rid of the 20 by subtracting it on both sides. Okay, I'm left with 2y equals 16 minus 20 is negative 4. Divide both sides by negative 2, and y equals negative 2. Alright, once again, I need to write my final answer in the form of a point. Here's my x value, y value. So the point is 5, comma, negative 2. Alright, let's just be thorough and check this one more time. So now I'm going to store 5 for x and negative 2 for y. So let's go to our calculator. So I'm storing 5 store for x, enter, and negative 2 storing that for the y value. Okay, so now the computer will store it and plug it in for us. First equation is 3x minus y equals 17. So let's go punch that in. 3x minus y, and let's see what we get here. We get 17. So let's come back here to our paper. So when I typed in the left side of this equation, I got 17. And look what the right side equals, 17. So the first one checks out. Now we're going to check the second one. So let's go type in the second part on the left side, 4x plus 2y. 4x plus 2y, and that equals 16. So let's come back here. So when I typed in the left side, it equaled 16. Bring the equals, look at the right side, 16. So this satisfies both equations. That is our right answer. Alright, so that is how you do solving equations or systems of equations by substitution. Alright, so now do the individual practice on your own. And once again, check your answers with your calculator. Store the values, plug it in.